Okay, I just want to make sure that we're on the same page about trig proofs. So I'm just going to do a little bit of review. You guys have seen this for months and months now, but I just want to make sure that we've warmed up a little bit. So before, I used to give you a right triangle, and I just gave you this neat little mnemonic device called SOHCAHTOA. Now, SOHCAHTOA refers to the sine of an angle, the cosine of an angle, and the tangent of an angle, and what they mean. The sine of an angle is the ratio of an angle's opposite side to its hypotenuse, SOH. The cosine of an angle is the measurement of an angle's adjacent side to its hypotenuse, kah. The TOA, tangent, the tangent ratio is the ratio of an angle's opposite side to its adjacent side, TOA, tangent of theta. So in this diagram, let's just say I give you a right triangle, the angle is theta, and we've got legs A and B, and the hypotenuse is C. So we know the three trig functions. The sine of angle theta is the measurement of the opposite side to its hypotenuse. Therefore, the sine of angle theta is A over C. The cosine of angle theta is the measurement of the angle's adjacent side to its hypotenuse. So the cosine of angle theta in the diagram would be B over C. And the tangent, as far as we know, you'll find out later today that everything you know is a lot. No, I'm just kidding. No, the tangent of angle theta is the measurement of the angle's opposite side to its adjacent side for now. It is A over B. Okay? Then we learned about three more trig ratios. They're called the reciprocal trig functions. And they are, in order, the cosecant, the secant, and the cotangent. So reciprocal, if you go back to middle school math, you'll remember that the word reciprocal is the flipped version of the fraction. So if we know that cosecant is 1 over sine, that means that the cosecant ratio is the reciprocal of the sine ratio. And the secant is the reciprocal of cosine, 1 over cosine. So therefore, secant is the reciprocal of the cosine ratio. And cotangent is the reciprocal of tangent. Cotangent is 1 over tangent. Therefore, what's the reciprocal of the tangent ratio? So if we know that sine is A over C, then the cosecant has to be C over A. If we know that the cosine is B over C, then the secant ratio must be C over B. If the tangent of angle theta is A over B, then the cotangent, the reciprocal of tangent, should be B over A. Just to review, we need to know what these mean. Okay, let me just make sure, no spoilers. Okay. So now, just to review, I give you the diagram of 3, 4, 5. Find all 6 trig ratios for angle theta. So look at angle theta, find the sine, cosine, tangent, cosecant, secant, and cotangent independently. Okay, so since you've paused the video and done the work on your own, let's take a look at the results. Well, the sine of angle theta is the opposite over the hypotenuse, 3/5. The cosine of angle theta is the ratio of an angle's adjacent side to its hypotenuse, 4/5. The tangent, for now, is the ratio of an angle's opposite over adjacent, or 3/4. And now we're going to take a look at sine, cosine, and tangent and take their respective reciprocal. So since cosecant is equal to 1 over sine, and the sine is 3/5, then cosecant is equal to 5/3. Since the secant is the reciprocal of cosine, secant is equal to 1 over cosine, that means that the cosine of 4/5 gets flipped. Sorry, the cosine of theta is 4/5. That gets flipped to become secant is equal to 5/4. And finally, the cotangent, which is the reciprocal of tangent. Cotangent is 1 over tangent. That means that the cotangent of angle theta should be 4/3. Okay, now that we got that out of the way. So remember when I said for now, for now, for now? Well, here's the now. So before we defined the tangent ratio as the ratio of an angle's opposite side to its adjacent side. Well, now we're in the world of trig proof. So what is the formal definition of the tangent ratio? So we're going to get rid of opposite and adjacent after today because everything in trig proofs can be broken down into sine and cosine. Sine and cosine are going to be the building blocks for what we're going to be doing for this unit. So, oddly enough, the tangent ratio is formally defined as the ratio of the sine over the cosine. I just want to ease your anxiety that even though it's technically true that the tangent is opposite over adjacent, its formal definition is that the tangent is equal to sine over cosine. But we can prove that. So let's see. We're going to prove that tangent of theta is equal to opposite over adjacent, knowing that tangent of theta is equal to sine over cosine. So I'm going to give you guys time to draw this diagram. Okay, I didn't do the proof here because I realized I would need more space, so I did it on the other side. So for now, get this in your notebook, pause the video, and then we're going to prove this. Okay, so let's look at this piece by piece. We're going to prove that the tangent of angle theta is equal to the opposite over the adjacent. Well, first things first, if we know that tangent by definition is sine over cosine, let's take a look at the side lengths of this triangle. If we look at angle theta, we notice that the opposite side of angle theta is A, the adjacent side of angle theta is B, and that the hypotenuse of angle theta is C. Okay, that's going to help out a lot. So if tangent is equal to sine over cosine, and I just want to make a little note to this, like when I was talking about my college experience, I got into math so I didn't have to cite my sources, so I didn't have to write any more papers. It turns out I am citing my source, like in social studies class or English class. I'm doing it with the rules. So the black is what I'm doing. The red is what rule I'm citing. Okay? So the tangent of angle theta by definition is sine over cosine. Moving on to the next step, I'm just going to rewrite sine over cosine as a division problem. You don't have to write that part. I'm just showing you what exactly I'm doing. So I've literally rewritten the fraction sine over cosine. Sine over cosine is a division problem. Sine of theta divided by cosine of theta. Okay, now I'm going to plug in the sine ratio. Well, the sine of angle theta is A over C. And the cosine of angle theta is B over C. So now I'm going to plug in A over C for the sine and B over C for the cosine. Now, go back to the rules of dividing fractions. If I'm going to divide fractions, I'm going to leave this first part alone. I'm going to turn division into multiplication and B over C, so the second part of the division problem, called the divisor, becomes the reciprocal. So bring down A over C, turn division into multiplication, and turn the divisor into its reciprocal. So bring the dividend down. Dividend, yeah, that's a big vocabulary word, aka the first number in the division problem. The division turns into multiplication, and B over C becomes C over B. Because when you divide fractions, that means you multiply by the reciprocal. So now that I've got A over C times C over B, let's just multiply across. We've got AC over CB. Okay, well, can I simplify this fraction? Yes, you'll notice that there's a C on the top and a C on the bottom, so those can cancel out. AC over CB. And because C over C is equal to 1, C over C can cancel out, leaving me with just A over B. Well, hey, go back to the diagram. A is the opposite side, B is the adjacent side, so we just conveniently in geometry call it opposite over adjacent. Okay? We just conveniently call that in geometry to make our lives easier, but the tangent by definition, as you get higher and higher into high school, is sine over cosine. Okay? So now, here's the list of rules that you're allowed to use for now. It's going to get bigger and bigger. So think of this like a video game where it's an RPG. These are the weapons that you're allowed to use for your character. And as time goes on, this toolbox is going to get bigger. The list of rules is going to get bigger. But for today and the next video, please note that these are the rules you're allowed to use. Okay? And as time goes on, you're going to, like, I can't hold the iPad and stretch out at the same time, but you know that stretch where you cross your arm and stretch your tricep and do the other side. You do arm circles, you bend down and touch your toes, you do all that stuff in PE class. You're warming up. For now, I'm going to make your life easier and say these are the rules that we're going to use today and the next video, and so on and so forth. So by definition, we can say everything is sine and cosine. Sine can't be broken down, cosine can't be broken down, but tangent can be broken down into sine over cosine. Okay? Cosecant is the reciprocal of sine, so cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. And cotangent is equal to 1 over tangent. But that's not going to help me in the long run unless I know that tangent is sine over cosine. So if the reciprocal of tangent is cosine over sine, that is the same thing as the cotangent ratio. So therefore, I can use any of these rules at my disposal today and the next video. Okay? So keep this on the side, and we're going to refer to it. Okay? So I'm going to keep these papers both in the same spot. So let's start with problem number 1. How do I prove using these rules? Sorry, move this paper out of the way. I don't need you anymore. How do I prove using these rules that sine times cosecant is equal to 1? Thank you, man. The mailman came. So sine times cosecant is equal to 1. Well, we start with the left side. Is there anything that's going to help me prove that the left side equals 1? Note, you can't just plug in for any angle. Let's go with 30 degrees. So, well, sine of 30 times cosecant of 30 is equal to 1. Oh, that works. Note, show using the rules. Okay, well, I notice in particular, let me get my red, that this cosecant of theta can be rewritten. So I'm going to call this sine of theta over 1, because I can. Anything can be rewritten as that itself over 1. But I know that cosecant of theta can be rewritten as 1 over sine of theta. And I'm just going to highlight that part right there, that you're important because you can be transformed. By definition, cosecant of theta is equal to 1 over sine of theta. I'm citing my source because you guys know what I'm doing. Okay, so now I'm just going to combine them into one neat little fraction. So now I multiply across. Sine times 1 is sine. 1 times sine of theta is sine of theta. Okay. Sine of theta divided by sine of theta is equal to 1. Check. So we start with the left, we manipulate it using the rules to make it equal to the right. So this is like a maze. You navigate your way through the maze and we get to our goal. Okay? This one's kind of similar. Prove that secant of theta times cosine of theta is equal to 1. I'm going to let you pause the video and see what you can use. Okay, so we start out with the left side. The left side is secant of theta times cosine of theta. Is there anything here that I can use in my list of rules that's going to help me make the right side equal 1? Well, cosine I can't really break down otherwise, unless it's cosine over 1, in which case it's pretty obvious. But you notice that this secant can be changed. The secant of theta can be rewritten as 1 over cosine. So I'm going to rewrite this as 1 over cosine of theta times cosine of theta over 1. And the reason why I can do that is because by definition, secant of theta is equal to 1 over cosine of theta. What I'm doing on the side is citing my rule. Okay, now I'm going to multiply across. 1 times cosine of theta is cosine of theta. And cosine of theta times 1 is cosine of theta. Hey, I don't care what angle you use. Cosine of theta divided by cosine of theta is 1. Right? A number divided by itself is 1. So therefore, we have proven that the left side equals the right side using the list of appropriate rules for trig proofs. Okay. Now I'm going to make it a little bit harder. Again, the outputs are still going to be 1. So rule number 3, tangent of theta, cosecant of theta, cosine of theta is equal to 1. So tangent times cosecant times cosine is equal to 1. Use these rules that help us navigate through and make the output equal to 1. So if you want to do this on your own, go for it. Okay, I assume you've paused the video and done this on your own. Well, oh boy. So can I rewrite tangent? Yes, so let me get my multicolored pen since I'm going to be using 2 colors here. So I'm going to rewrite tangent as sine over cosine, right? And you don't have to do this in color. I just like to use color because it helps me out. So tangent can be rewritten as sine over cosine. Cosecant can be rewritten as the reciprocal of sine, so that's 1 over sine of theta. And cosine can't be broken down, but I can still make this cosine over 1. So you see, tangent is equal to sine over cosine. Cosecant is equal to 1 over sine. So I'm going to put that on the side over here. Cosecant of theta is equal to 1 over sine of theta. And tangent can be rewritten as sine over cosine. Okay, so now that I got these out of the way, let's just combine them into one neat little fraction. Okay, sine times 1 times cosine, well, that's just sine times cosine. Cosine times 1, well, that's just cosine of theta times sine of theta. Okay. Even though I could cross out right now, I'm just going to rewrite it just to show you, okay, can anything on the top and bottom cancel each other out? Okay, we've got a sine on the top. That cancels out with sine. And we've got a cosine on the top. That cancels out with the cosine on the bottom. So if everything on the top cancels out with everything on the bottom, that means that we've got 1 over 1, or 1. All right, finally, prove beyond a shadow of a doubt, prove with the list of rules that are appropriate for this unit that secant times cotangent times sine equals 1. Okay, well, I'm going to take a look at secant. Well, you don't have to do this in color, but I'm targeting it. Secant, according to our list of rules, is 1 over cosine. So I'm going to rewrite this first factor as 1 over cosine. And cotangent, can I rewrite that? Yeah, I can rewrite cotangent as 1 over tangent, but if I want to break it down even further, I could write this as cosine over sine. And finally, can I break down sine? Not really. But you know what I can do is I can make this sine of theta over 1. And again, I'm just going to cite my rule on the side just to make sure that we're clear. Secant is equal to 1 over cosine. And cotangent is equal to cosine over sine. Sorry about that. So now I'm going to put it all together. 1 times cosine times sine would be cosine times sine, cosine of theta times sine of theta. Cosine of theta times sine of theta times 1 is cosine of theta times sine of theta. Hey, if I look at this problem, can anything cancel out on the top and bottom? Yeah. So I'm just going to rewrite it. You can cancel out right now if you'd like, but I'm just showing you step by step how do we get there. So if cosine is on top and cosine's on the bottom, if we have multiplication, all multiplication on top, cosine cancels out with cosine, sine cancels out with sine, and if everything on the top cancels out with everything on the bottom, then we get 1 over 1. So therefore, it's 1, which is exactly what we wanted. It's like navigating a maze. Start somewhere, end somewhere, but get to your goal. And I'll show you various techniques on how to get to your goal in the next video. Today we did left proves right. Have a great day.